Good morning, students. In this video we are going to discuss about some friction based problems. Here two blocks are resting on the horizontal surface and the two blocks tied with a flexible cable. Okay, now we are going to study about the question. Two blocks with masses A and B. Mass of A block 20 kg and mass of B block 80 kg are connected with a flexible cable that passes over a frictionless pulley as shown in the figure. The coefficient of friction between the blocks is 0.25. If motion of the blocks is impending, determine the coefficient of friction between block B and incline the surface and the tension in the cable between the two blocks. So in the question, mass of the block A 20 kg, first one, mass of the block B 80 kg, the second one. Then the both blocks are connected between the flexible cable that is over a frictionless pulley. So the friction between the pulley and cable is neglected. The coefficient of friction between the blocks A and B is 0.25. If motion of the blocks is impending, the motion of the block is impending mean type of motion is given in the question indirectly. So determine the coefficient of friction between the block B and the inclined surface we need to find out, and the tension in the cable. So first one, whatever the question given in the problem, we need to draw the free body diagram for given one. First of all, we need to consider the less number of force acting block. So block A, among these two, A block consider only less number of forces. So block A here consider as a free body diagram. Tension in the cable attached. Then the reaction force acting. Then applied force. There is no applied force on the block A, so self weight of the body considered as a applied force. That applied force should be resolved into horizontal and vertical manner. The reaction force also considered into friction resistance force and normal reaction force. Then it can be considered as x direction and y direction for our simplifying purpose. So we are going to apply the equilibrium law of forces. Summation of all the forces acting in y direction should be equal to 0 mean here normal reaction force, this is block A, so it is considered as AN, normal reaction force AN, minus, because the self weight of the body acting towards downward direction, so that 196.14, usually it's in given in the question 20 kg, so multiplied with gravitational force it will give 196.14. Again that is converted into vertical manner, so the self weight of the body resolved into vertical and horizontal force, so that is converted into 196.14 cos 35. So that will give you reaction force at the block A is 160.67 Newton. Then we are considering the type of motion. For impending motion of the block A, AF equal to mu s into AN. So we are applying second equilibrium law of forces. So summation of forces acting in x direction is 0. So T acting towards upward direction minus T. Then AN consider here 0.25 into 160.67 because mu into AN, AF equal to mu s into AN. So this AF mu 0.25, AN 160.67 plus this value 196.14 resolved into horizontal manner, so Px 196.14 into sin 35. Here cos 35 consider as Py Sin 35 consider as Px. So that will give you tension in the cable. So second one, we are going to draw free body diagram for block B similar to block A. Now the block B, considering various forces, self weight of the body block A and self weight of the block B, applied forces on A, frictional resistance force AF, frictional resistance force of BF, normal resistive force on BN, then tension in the cable. So all these values are listed in the figure. So here self weight of the body block B 80 kg multiplied with gravitational force, that will convert it into 784.56 Newton. Then we are applying equilibrium law of forces, summation of forces in y direction, that will give you Bn, normal force acting on the block B 803.34 Newton. Summation of force acting in x direction Bf 257.17 Newton. So we need to submit all the values in x direction and y direction individually to get the different answers Bn and Bf. So coefficient of friction between the block B and surface, inclined surface, is Bf by Bn, that will give you 0.320.